4:1. So most of this chapter is going to be congruent triangles, but for today we're just going to talk congruent figures in general. We will talk triangles a little bit, but just in general, what makes two figures congruent, okay? So in order for figures to be congruent, we need to have the same size, and shape of the figure. You can slide the figure to a new place, flip it, or turn it, and it will still be a congruent figure. So I'm going to show you what those three things look like, and then we'll get into kind of the parts that you have to work with here. So one of our options here is if we start with a rectangle, okay, and I want a congruent rectangle, I could just slide that rectangle over here and pretend they look congruent. My drawings are not perfect, but this would be a slide. It just slid to a new place, but it's the exact same figure, just slid over, okay? It didn't turn at all, didn't flip over, it just slid to a new spot, okay? Second one is a turn. If I have a triangle that looks like this, and then a triangle that looks like this, I just took this triangle and I turned it, I rotated it, right? Would be another way to say it. Still the same figure, it's still the same triangle, so we would say those are congruent triangles. We just turned it, we rotated it. Okay, and then the third thing that you can do is you can flip the figure. So say we have this figure and it becomes that figure, right? So we just flipped it over. Sorry, I didn't write the other one in. This is a flip. This is a turn. So any of those moves will still keep a congruent figure. It just can't change shape at all, and it can't change size. So if it's this big, it can't become this big, right? It's got to stay the same size and the same shape, and then even if it does these three moves, it's still considered congruent to what it started as, okay? So we're going to talk about congruent polygons. So what you need to know is that congruent polygons, do you know what a polygon is? A figure. It's a closed figure with three or more sides, essentially, like a triangle or a rectangle or a pentagon or a hexagon. Those are all polygons, okay? So congruent polygons have to have congruent corresponding parts. Okay, so what we're going to really be looking at here is the parts of a polygon having to be congruent would be your sides, the lengths of your sides, and the measures of your angles, okay? So think sides and angles here. So let me give you a couple polygons, and we'll talk about what matches up. Remember when we talked corresponding angles? We said from a vertex, it was like the top left with the top left, right? On two different figures, corresponding parts are the parts that match up if you were to lay them on top of each other, right? So if you laid it perfectly on top of each other, what matches up there? So let's say you have these two figures. Just going to do similar to what we did on the flip there. If this is A, B, C, D, and this is H, I, J, and K. Okay, so often they're going to tell you two figures are congruent. So they'll say like A, B, C, D is congruent to, and you have to match up the corresponding parts. Your orders have to be the same. So if I'm talking A, B, C, D, what figure am I talking about on the right? H-I-J-K. Okay, so here's the beautiful thing about congruent figures. Whatever they give you here, the name of it, you don't even need pictures to know what's the same then, right? I could totally ignore my picture right now and just look at the letters and see that angle A is going to correspond to angle H because they were both the first letter. And see that angle D is going to be congruent to angle K. Okay, so when they say give me the congruent corresponding parts, we're going to match up all the angles and all the sides that would be congruent corresponding parts. So for instance, I can say right now, angle A is congruent to angle H. Okay. I could also say angle B is congruent to what? Angle I. Okay, so the second letter with the second letter. I could say angle C is congruent to angle J. So 3 arcs here with 3 arcs here. What? Okay. And then angle D is congruent to angle K. So when they ask you to fill in what are the congruent corresponding parts, they want those 4 angles matched up, okay, 4 pairs of angles. But then they also want segments. So give me segments that are congruent here. What is segment AB going to be congruent to? AB would be congruent to IH. You can write it IH or HI. It's still the same segment, right? I usually just try to keep them in the same order, but IH is fine. So AB is congruent to HI. So if you look at the picture, it's the first 2 letters with the first 2 letters, right? So like I said, you don't need a picture to be able to do this. It's actually probably less likely you make mistakes if you don't look at the picture. If you just match up the letters, that's totally fine. Give me another pair of congruent segments then. AD and HK. So AD is congruent to HK. What's DC congruent to? DC is congruent to JK. Okay, and remember how we mark them, right? Double arc or double hash marks, triple hash marks. So just keep more hash marks each time. If that helps you to see it a little better, you're welcome to do that. And then the last one would be BC is congruent to IJ. Okay, so when they ask you to name the congruent corresponding parts, that's what they're looking for. The angles that match up and the segments that match up. Okay? Okay, so I'm going to draw you a picture. We're just going to do a triangle, so it'll be a little less involved. But I'm going to show you where the letters help a ton because it's going to look a little less simple in these pictures. So if this is triangle TJD, and this is triangle you got to pretend they look alike. RCF. Okay, they're going to tell you at the beginning of the problem what is congruent. So in this problem, they'll say triangle TJD is congruent to triangle RCF. Okay, and then they'll say name the congruent corresponding parts. So that means they want 3 sets of angles that are congruent and 3 sets of sides that are congruent. Can you tell me anything that's congruent? If it's triangle TJD and triangle RCF, what corresponds to point T? R. So the first one here matches up with the first one here, right? So we would say, if we look at angles, angle T has to be congruent to angle R. Give me another pair of angles that are congruent. J and what? J and C. And then angle D has to be congruent to angle F. Okay, so you're just matching up the parts that match up. How about segments then? What is TJ congruent to? RC. Segment TJ is congruent to segment RC. Segment JD is congruent to what? CF, right? If you look up here, JD is the second and third, so you do second and third over here, CF. Okay, and then you have to do first and last for your last one, right? T and D, so TD is congruent to, which one? FR, or RF, either way. Okay, so you're just matching up congruent angles, congruent sides. Does that make sense? Pay attention to this. Whatever they give you is going to help you with 10. Okay? Okay, so let's say we know that two triangles are congruent. Let's say we have this triangle and we have this triangle, and this is ABC, and this is F, D, and E. This angle up top is 30 degrees. And we're going to say this one down here is 74. And I'm going to tell you that triangle ABC is congruent to triangle DEF. We're going to find the measure of angle D and the measure of angle F. Give me a second to finish drawing that. Okay, so here's the deal. Looking at what they're telling us, triangle ABC corresponds to DEF. Did our triangles flip, turn, or slide?
Yes.
It flipped, right? Because A corresponds to D. So if you look where A is, over here, it's D, right? So it flipped over. That's probably the biggest thing you got to pay attention to on these is a lot of times people see a triangle and it looks like they're the same triangle if you just slide them over. Just be careful with that, okay? Because it actually did flip. You got to pay attention to those letters. So A and D are going to be the same measure, which means what about angle F? It's 74, right? These two are going to be the same also. So angle F is going to be 74. Okay, how can we find angle D then? They equal 180 with what other numbers? So angle D and what? Add up to 180. 30 and 74, right. So if we just call this X for now, okay, you can say X plus 30 plus 74 should equal 180. So if we take this away, that would be 104. So X comes out to 76 degrees. That means the measure of angle D is 76 degrees. Okay, what would the measure of angle A be? 76 also. It just flips over onto that same picture. So these would both be 76. Okay, questions on that? That a hand up? No? Okay, that's okay. Just making sure. Okay, so here's where we're going to start seeing some proofs. And this first one is going to look like proof format. I'm not telling you like prove Well, I am telling you. I'm telling you to prove the triangle's congruent. So what did we say we need to know in order for figures to be congruent? What has to be true about them? Same angles, same sides, okay? So here's what we're going to do. This is example 3. They're going to ask, are the triangles congruent? And you need to justify your answer. So whenever they say justify, it's prove it, right? Prove to me they're congruent. So here's the triangles you're going to start with. Pretend they look congruent. Okay, so here's the deal. Whenever you see a picture of two different figures, whatever they mark for you with the arcs, okay, so with these arcs or with these hash marks, whenever those are marked for you, your reason for that, any guesses? Given, okay? So whenever you see markings, given. Anything else, you have to prove why it is what it is, okay? So here's what we're going to do. We're going to talk through this picture and see why we know that these two triangles are actually congruent. So what is our given information? Angle A is congruent to what? Angle E, the single mark, right? We know angle B is congruent to angle D, and we know segment AB is congruent to segment DE. Okay, so all of those are marked with arcs or hash marks. That is given. Okay, so we're going to say given there. So we currently have 3 of the 6 things we need proven already because they were given to us. So we just need to figure out the other 3 parts, right? 3 angles, 3 sides that match up. The first 2 seem a little ridiculous, but you'll get a feel for why it actually matters down the road. First thing we can say is segment BC is congruent to what? What? CD. Why do I know BC and CD are congruent?
Given.
It's not given. They're not marked congruent. Right. What does that mean?
That they're congruent.
They have the same length, right? So segments that have the same length are congruent. So all you have to say here is that BC equals 4 and so does CD. Okay, they both equal 4 is your reason. Technically it's not given because it's not marked with the hash marks, okay? In that same step, I'm going to lump with it the AC congruent to CE because AC equals 6 and so does CE. Okay, so you can call that step 3 if you want, or we can just lump it as step 2. It doesn't really matter. So what's the only thing we haven't proved of the 3 angles and the 3 sides right now? Do you see which? Is it an angle or a segment? Angles. It's C. You can't name it C because it's got multiple angles coming off of it, right? So we would say angle BCA is congruent to angle, what angle would that be? BCA and DCE. And why do we know those are congruent? They're vertical. So you're just going to say vertical angles. Okay. So now we can say triangle ABC is congruent to triangle, and you have to match up the corresponding parts. So if it's ABC, what triangle is it congruent to?
FCD.
E. E. Wait, say it. What'd you say? DC. EDC. So we went from one arc and one arc, right, to two arcs, two arcs. So if it went A, B, C, 1 to 2 to 3 arcs, you have to go 1 to 2 to 3 arcs. So E, D, C. And the reason we know that is the definition of congruent triangles. We said in order to know two figures are congruent, we need to know their segments and their angles match up, okay? So this is what your proofs today are gonna look like. You have to prove all 6 things. These 3 angles, these 3 segments. Beyond this, it's usually you have to prove 3 of the 6. So today might feel a little lengthy. I promise it gets shorter, okay? So there's a theorem you're going to use that will help you do all of these angles congruent. It's called the third angles theorem. Okay, and third angles theorem says this: if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. Okay, if 2 angles of one triangle are congruent to 2 angles on another triangle, their third ones would have to be congruent also. Why? If I gave you this triangle here and this triangle here, and this was A, B, C, and D, E, F, and I told you A was congruent to D and B was congruent to E, the third angles theorem says then angle C has to be congruent to angle F. Why does that third angle have to be congruent? What do we know about triangles? They always add up to 180. So if we were to take A and B away from 180 and D and E away from 180, because those are the same, the third ones have to be the same as well. Okay, so if you know 2 sets are congruent, then the third sets will be congruent also. Okay? How are we doing on that? So far, so good? Okay, then we're gonna do one more proof and then we're done. This one's shorter because you have a lot of given information here. And this one's gonna look like an actual proof. So this is example 4. They are gonna say, given all of this, LM is congruent to LO, MN is congruent to ON, angle M is congruent to angle O, and angle MLN is congruent to angle OLN. They want you to prove triangle MLN congruent to triangle OLN. Okay, and here's your pictures, and then I'll give you a little time to catch up. So I promise I'll slow down, but you can at least draw it all out. Because when you draw it, you're able to mark it up, and when you mark it up, it leads you to where you're supposed to be finding information out. If you don't mark things, sometimes you miss where it was trying to lead you. So if I were you, I would draw the picture every single time, okay? Some of you won't need to, but I need to. A lot of people need to. So I highly recommend you draw it. The other thing is whatever is given, if it's not marked for you already, which most of the time it is, but if it's not, mark it. So for instance, they told us LM is congruent to LO, so mark that congruent, okay? They also told us MN is congruent to ON, so mark it, okay? They told us angle M is congruent to angle O, and they told us MLN. And for some reason this confuses people. We learned it in chapter 1, but we haven't done a lot with it. When you name an angle with 3 letters, what's your vertex? The middle letter, okay? So MLN is from M to L to N. That's this angle right here, okay? OLN is this angle. So those are congruent. All right, so we're trying to prove the 2 triangles congruent. We have 2 sides that we know are congruent, and we have 2 pairs of angles that we know are congruent. So we need 1 more pair of angles and 1 more pair of sides. So, first step. What is our first step?
Given.
The given, okay? Step 1 is always the given. So I'm just going to take this. Don't rewrite it. That's too much writing for no real reason. Just drop it in there, okay? We know that to be true. So now what we have to look at is if we're trying to prove the triangle's congruent, what is our missing set of angles and what is our missing set of sides and why do we know they're congruent? So our missing set of, let's start with sides. The third side on the top triangle is what segment? Which side don't we have marked congruent to another side? LN, right? This side here is the third side on the top triangle, but it's also the third side on the bottom triangle. So we're basically saying right now that LN is congruent to LN. What is that? Reflexive, okay? You're gonna see the reflexive property, I bet, in like 85% of your proofs. So look for a side that is shared. This is where reflexive property matters. This is why we learned reflexive property a little while ago. So the reflexive property says those 2 segments are congruent. So now if I were you, I would mark it congruent, right? 3 little hash marks. So now we can see all 3 sides on one triangle are congruent to all 3 sides on the other triangle, okay? The only other thing we're missing is an angle. And if you look at the angles here, we would say angle MNL is congruent to what angle? So if I said MNL, then I would say, I'm going to say ONL just so we're matching up corresponding parts. But you could say that one because that's still angle N. Can anyone tell me why they're congruent? It's the third angles theorem, right? We knew the 2 angles were congruent, therefore the third ones have to be as well. So this is third angles theorem. Okay, so you look at your picture. All 3 sides are marked congruent to all 3 sides on the other triangle. All 3 angles are marked congruent to all 3 angles on the other triangle. So what they asked us to prove that the triangles are congruent has been done. Why? Definition of congruent triangles, right? Congruent triangles have to have 3 pairs of corresponding sides and 3 pairs of congruent corresponding angles. Okay, so that's what a lot of your proofs are going to look like today. Like I said, beyond this, we speed them up a bit because I give you shortcuts for not having to prove all 6 things. You'll have to prove just 3 of them instead. But for today, just to get a feel for what congruent triangles are, this is what you're doing. Any questions on that?